Okay, welcome back. Um, we want to work with the square root property, completing the square. This is 11.1, by the way. And then we'll have the distance formula, which is important in math. Um, a lot of math is just about measuring things, okay? So, uh, yeah, I mean, there's a lot of neat stuff in math, but there's a lot of sort of important stuff which isn't all that glamorous. And measuring things is definitely something very important to people, but maybe is not as cool as geometry and stuff like that. But um, anyways, this is 11.1, and we're talking about the square root property. Move things a little bit just to make everything function. I need it. Move that there. All right, 1 second. Sorry. I can fast forward while I'm doing this. Okay. Square root property. There's also this thing called completing the square. And then we care about the distance formula. So basically just measuring the distance between 2 points. And then finding the halfway point in between 2 points. So the midpoint formula as well. Okay, so first we'll deal with the square root property. And it's really just a shortcut formula for solving things like x squared equals 9. Okay, so this is actually a quadratic equation. We can move the 9 to the other side, so x squared minus 9 is 0. And then to solve it, we would factor this thing. So it's a difference of squares. You would write x plus 3 times x minus 3 is 0. And then you could write x plus 3 is 0. In other words, x is negative 3. And then x minus 3 equals 0. Maybe I should write that out just in case you forgot. So x plus 3 equals 0. And when you subtract 3 to both sides, you get minus 3. Or x minus 3 is 0. And then when you add 3 to both sides, you get x is 3. Right? So those are your two solutions to this guide, but there turns out to be a shortcut. So if you note that, or if you sort of do enough of these problems, you'll see a pattern, okay? And basically, you can think of it kind of as taking the square root of both sides. So if you do take the square root of both sides, you'll have x squared equals square root of 9. And then we'll presume that that means x equals plus or minus 3. Okay. If you remember, the square root of something squared is the absolute value of that something. Okay. So really, what we're doing is listing all the solutions to this absolute value equation. And so if you put in 3, the absolute value of 3 is 3. If you put in negative 3, the absolute value of negative 3 is 3. So it seems to work. Okay. But in general, what we're going to just assume from this point on, right? We're not going to go through all the rigmarole every time. If you have u squared equals d, then you can automatically conclude that u equals plus or minus square root of d. So we won't have to go through all these steps. We'll just go from here to here. Okay, now we want to look at some variations on this theme from the book. So here is 3x squared equals 75. If I divide both, I want to isolate the x squared term so I can use this square root property. Right? So you have to get this x squared all by itself. So I'm going to divide both sides by 3. And I'll have x squared is 25. And then I can say that means x is plus or minus square root of 25, which of course is 5. So it may look like it's just one answer, and this is a little misleading. It's x equals plus or minus 5 or something, some object which has both plus and negatives to it. But it's really what they're talking about are two solutions, x is 5 or x is negative 5. And you could always split these objects up in this way if you want to. I mean, think about where our sort of intuition of this problem comes from. It's from solving this quadratic equation, and of course we get 3 and negative 3. This is just a shorthand notation for that. Let's look at 7. So I have 3x squared minus 2 is 0. Again, I want to get the x squared all by itself. So I need to first move the 2. So I add 2 to both sides. Then I want to move the 3 over. Okay. And then I'll do the square root property. So x equals plus or minus square root of 2 over 3. And then we want to usually you want to rationalize the denominator for your teacher. So the way we could do that is split up the numerator and denominator. And, you know, the plus minus you could just carry over each step. You don't have to do anything special. You just keep the plus or minus in front to remind your reader that there's two answers, a positive and a negative. To rationalize the denominator, you can just multiply by the denominator, which is nice. Okay, so I end up with plus or minus radical 6 all over radical 9. The square root of 9 is 3. And that'd be it. Okay. So you get two answers, radical 6 over 3 or negative radical 6 over 3. Okay. Let's keep on moving now. So we have number 9. 25x squared plus 16 is 0. And again, the game is to get this guy by itself. So I'll move the 16 over. So I have 25x squared is negative 16. Square root, oh wait, I still have to get the x squared by itself. So I divide both sides by 25. Okay, then x squared is negative 16 25ths. Square root property, x must be plus or minus square root of negative 16 over 25ths. It has a negative inside the root, so that's going to end up being an imaginary. And in this section, you're going to think in that way. You know, sometimes if we would be looking for the solution here, we would just say there's no solutions if all we care about are real numbers. But if you care about the imaginary, the complex numbers, then you are going to include this I. Okay. Then the square root of 16 25ths is just 4/5. So I have plus or minus 4/5 I. Let's look at 16. So I have 3 times x plus 2 squared is 36. I need to isolate this item here. It's whatever is squared, you're isolating that. And, you know, and before we just had a single term squared, but here we have a binomial squared. That's okay. This is just turns into the thing you want to get by itself. So divide both sides by 3. And then you could apply the square root property. So I have x plus 2 is plus or minus square root of 12. I need to isolate the x, so I'll subtract 2 to the other side. So I'm going to put that in front. You don't want to put plus or minus radical 12 minus 2. It's always the second part is the plus or minus part. Okay, so negative 2 plus or minus radical 12. I'm going to start factoring out the perfect square part. Okay, so I end up with x is negative 2 plus or minus the square root of 4 is 2, and then radical 3. So that was 16. Let's take a look at 19. So here we have x plus 3 over 4 squared equals 11/16. Right? This time the squared term is isolated, so I just do the square root property, and I'll have x plus 3/4 equals plus or minus square root of 11/16. I want to subtract the 3/4 over, so I'll get x equals negative 3/4 plus or minus, and we could do the quotient property of roots to rewrite this as square root of 11 all over square root 16. And then we can rewrite that again. It'll be negative 3/4 plus or minus square root of 11 all over square root of 16 is 4. Okay. One more, and then we'll move on to completing the square. So here's 22. I have x squared minus 6x plus 9 is 49. Okay, we want to set it equal to 0, so I'll subtract 49 on both sides. Okay. So one thing you could do then is just factor it. I don't see why we make a big deal out of this, but oh, I see. I'm sort of making a mistake. They wanted me to do it with all right, I see. So sorry about that. Let's not go in that direction. That's the way we usually do it. That wouldn't make any sense in this context, though. What we want to do is rewrite this sign. Okay, so that's what they want you. They want you to say, oh, that's the same as x times 2 binomial. So we're factoring it, right? So the signs have to be minus minus. That has to be 3 and 3. And so that'll be x minus 3 squared equals 49. And then they want you to do the square root property. And so it'd be x minus 3 equals plus or minus square root of 49. And then you can move the 3 over, so you get 3 plus or minus 7. So the two solutions, if you break this apart then, 3 plus 7, which is 10. And then on the other hand, x equals 3 minus 7, which is negative 4. So you can use the square root property to as a different way of solving these traditional quadratic equations. So let's see, this may or may not help, but let's just go ahead and solve it the old-fashioned way, right? Let's see if we can factor it. And we should get the same answer as what we get over here. So the signs have to be plus minus. And then we're thinking probably 4 and 10, right? So the bigger number has to be negative. And yeah, we're going to end up with the same answers. So that's kind of interesting. I don't know. It's just giving you a different way of solving these problems. Oops. Yeah, so let's move on then to completing the square. So I think the idea is eventually we'll go back and be able to solve these kind of problems where you wouldn't be able to factor it. So you're kind of stuck and then like, oh, what do? I can't factor it. Well, it turns out you'll probably be able to complete the square and then find the solution that way. So completing the square anyways. How do I do this? Well, you're going to be given a quadratic form or a second degree polynomial of some sort, x squared plus bx plus c, and you'll add in this particular number b all over 2 squared. when you do that, it'll result in a nice polynomial where you can rewrite it like this. Okay? And then you could apply the square root property in the context of the problem you're trying to solve. At first, we're just going to work with figuring out what this guy is. It's b over 2. So let's take a look at example 5. Part A, we have x squared plus 8x. Okay, so in this case, the b value is it's always the thing in front of the x. Okay, so in this case, b is 8. So I'll have 8 all over 2 squared. 8 all over 2 is 4, and then 4 squared is 16. So that would be the number I would add in. And let's take a look at that. So if I go x squared plus 8x plus 16, I should be able to factor it real easily. And that both factors should be exactly the same. Okay, so it's like a perfect square. So the signs have to be plus, plus, and then for 16, so what times what is 16, but add the 8, and it's just 4 and 4. So you can rewrite that again then as x plus 4 times x plus 4, which is x plus 4 squared. Okay, let's get another one. The problem with these is sometimes you'll have to deal with some ugly looking fractions, okay? In the real world and later on in math, if you kept taking math, you wouldn't maybe encounter these all that much, but it's good practice just if you are going on, you know, you want a lot of practice. So in this case, the b value is, you know, -7, whatever's in front of x. So we'll have -7 all over 2 squared. Okay, so this will always be positive, and in this case, 49/4. So completing the square, it's x squared minus 7x plus 49/4. And then we could rewrite that as, and let's not write, you know, this times this. Let's just cut to the chase and put a square on there. Right? So it'll be x has to be minus minus to get this sign. And then the number that goes here is just always going to be the square root of 49/4, or square root of your b over 2 squared. Okay, so it's just going to be 7/2. And it looks weird because it's, oh, how do I have a non-fraction here even though my second term was a fraction? Maybe we should go ahead and expand it and just see what it is. Okay, so if you multiply the first together, you'll get x squared. The outer together is minus 7/2 x. The inner minus 7/2 x. And then the last is plus 49/4. Okay. So if you add these together, you're adding the numerators over a common denominator. Then you get x squared minus 14/2 x. So 7 plus 7 is 14. And then plus 49/4. And then, yeah, sure. So 14 divided by 2 is just 7. And so we got what we expected. Okay, so we should end up back sort of where we started. Zoop. Okay. So here's a real nasty one, part C. X squared plus 3/5 x. Okay, so this time the b over 2 is going to be a little bit different. So let's take a look. B now is 3/5, and then we're dividing it by 2. Okay, it's a complex fraction in there, but you can rewrite it literally. So 3/5 divided by 2, you can write as 3/5 times the reciprocal of 2. And of course, the reciprocal of 2 is 1/2. Okay. And then multiply that out, you get 3/10, sorry, and then square it. That'll be 9/100. Okay. So we add that in, you have x squared plus 3/5 x plus 9/100, which equals x plus 3/10 times x plus 3/10. Okay, so that's the idea of completing the square. Now we're going to use it to solve these quadratic equations. And so let's take a look. Part A, below the section we're in, solving quadratics by completing the square. And first things first, we're going to want to have a leading coefficient of 1. So if you look at my examples, whenever I was completing the square above, I always had a 1 in front of the x squared. Okay, the thing in front of the x squared is the leading coefficient. I always had a 1 in front of it. So first we need to get a leading coefficient of 1. Okay. So it may take a little bit of work to do that, and we'll cross that bridge though here in some of the exercises later. Okay. So just remember, you know, I'll remind you once we get there, but that turns out to be an issue. Okay. So anyways, let's look at 35. Hopefully I don't run out of room. We have x squared plus 4x is 32. So I want to complete the square over here on the 4x, based off the 4x. So I'll have b over 2, 4 over 2 squared. 4 divided by 2 is 2. Then I want to square it, and that's 4. Okay. So I want to add the 4 to this side, but if you add it over here, you're going to have to also add it over here. So you're going to end up with x squared plus 4x plus 4 equals 32 plus 4. Okay, so that completes the square. Now you want to factor. So over here, you should just have x plus blank squared. So in this case, it'll be x plus 2 squared. On the right-hand side, I have 36. And now we could use the square root property to solve this. So it's just x plus 2 equals plus or minus square root of 36, which of course is 6. And then you can subtract 2 from both sides. So you get negative 2 plus 6, which is 4. Or you get x equals negative 2 minus 6, which is negative 8. Okay. Okay, so let's look at a couple variations on this theme. 39. We have x squared plus, or sorry, x squared minus 8x plus 1 is 0. Okay, so what I'm going to do is move this guy over to the other side so it looks like the last kind of problem we were doing. So you see the last problem, how we had all the x stuff on one side and all the constants on the other. You want that form before you start completing the square. Okay, so x squared minus 8x. Subtract 1 on both sides. Okay. And then I complete the square. I have negative 8 over 2 squared. Negative 8 over 2 is negative 4. And then square it gives me 16. So I add that to both sides. So I get x squared minus 8x plus 16 equals negative 1 plus 16. Factor the left-hand side. Of course, x minus 4 times x minus 4 is x minus 4 squared. I probably should have just wrote that. square root property on both sides. X minus 4 is plus or minus square root 15. Add 4 to both sides. X is 4 plus or minus square root 15, and there it is. Let's try 45. 45 looks a little nastier because of the fractions involved. So I have x squared plus 4/7 x plus 3/49 is 0. And I'll go ahead and get the 3/49 to the other side. I need to complete the square, so I go 4/7 divided by 2 squared. 4/7 divided by 2 is the same as 4/7 times the reciprocal of 2. And the reciprocal of 2 is 1/2. So I have 4/14, which will reduce to 2/7. You don't see that. 2 goes in the 4 2 times. Then 2 times 1 is 2. 7 times 1 is 7. I still have to square it. 2 squared is 4. 7 squared is 49. Okay, I'm going to add that item to both sides. So I'll have x squared plus 4/7 x plus 4/49 equals 4/49 minus 3/49. Then I'll factor this guy, so it'll have to be plus plus, so I'll have x plus, and then the square root of 4/49 is 2/7. So it's always going to end up being the positive version of whatever the heck the b over 2 is. Okay. Squared. On the other side, I'll have 4 minus 3 is 1 over 49. Square root property now, so I'll have x plus 2/7 equals plus or minus the square root of 149 is 1 over 7. And then I'll subtract 2/7 to the other side. So 2/7 plus 1/7 is 3/7. Or, oops, it should have been negative 2/7, right? So negative 2/7 plus 1/7 is negative 1/7. Sorry about that. And then negative 2/7 minus 1/7 is minus 3/7 for my other solution. Right, so the fractions are a bit hairy. It just means it's more work. It's not like it's difficult or anything. It's just a little bit more work. You have to be careful. You have to remember all your little rules. Right? Let's look at 49. So 49 is one of the ones where the leading coefficient is not 1. Okay, so the thing in front of the x squared this time is not a 1. So in these previous examples, we always had 1 in front of the x squared. You know, if you don't see anything there, you always pretend it's a 1. Okay? So here now we have something other than 1 in front, and we're going to have to divide to get rid of it, or multiply by its reciprocal to get rid of it. Okay, so I'll have, well, first, business as usual, I want to get the 5 to the other side. So I'll have 2x squared plus 3x equals 5. Then I want to divide everything by 2. So this over 2, this over 2, this over 2. It's the same as multiplying both sides by 1/2. Right? So this will be x squared plus 3/2 x equals 5/2. Then I need to find or complete the square. So it's 5/2 divided by, 3/2 is the b value, divided by 2, and then square it. 3/2 divided by 2 is the same as 3/2 times the reciprocal of 2. The reciprocal of 2 is 1/2. Then I have 3 times 1 is 3. All over 2 times 2 is 4. Then 3/4 squared is 9/4. Okay, so that's what I'll add to both sides now. So I have x squared plus 3/2 x plus 9/4 equals 5/4 plus 9/4. Okay, so I'll collapse this side. It'll be x plus 3/2 squared. On the right-hand side, it's 5/4 plus 9/4, which is 14/4, or 7/2. Let's just cut the chase, or whatever they say. Cut to the chase. Square root property now, so you'll have x plus 3/2 equals plus or minus square root of 7/2. I'm going to move the 3/2 over, so x equals negative 3/2. I want to rationalize the denominator here, so I end up having to multiply both top and bottom by radical 2. Let's just cut to the chase again, right? So this would be negative 3/2 plus or minus square root of 14 all over the square root of 4, which of course is just 2 again. Okay, so that's the idea. Let's look at, I guess we'll look at one more. Do we need to look at one more? I'm kind of checking out things on how they go. Well, no, I think we're okay. Just a note that you can have imaginary solutions here. That is an issue, but we'll carry on. Okay, so now we're looking at some applications, and we'll see the distance formula after this section and the midpoint formula, and then we'll be done. But applications, the first application is from compound interest. And the formula is A equals P times 1 plus R. And then that's raised to the tth power. Okay, so A is going to be your future amount. So we're talking about putting money in a bank, something like that. Okay, so after a couple of years, how much money do I have in my account? P is the principal, which is the amount of money that you initially put into your account. Okay, so principal, hopefully I spelled that right. Principal, the principal is your pal, so I think it's principal, L-E. Then R is a rate. And when we use it in this equation, the rate will be used as a decimal. Okay, so if you've ever been to the bank, they have 3% rates or something like that. But we'll write it 0.03. And then T is going to be time. And for us, we'll be thinking in terms of years. Okay, so let's look at a checkpoint in the book. This is checkpoint 9. And they're telling us that our initial amount in the account is $3,000. And then after 2 years, the account has $4,328. Okay, so find the rate. Okay, so what we're going to do is just go to this formula and plug in all of our known information and solve for the rate. Okay, so the future amount is 4,320. The principal was 3,000. And then it's 1 plus the rate, which we don't know, so we'll just put R, raised to the tth power, and the tth power is 2. Okay, so it's basically a quadratics, just instead of having x, you have r. And we can use a square root property on it, right? It's a just like what we started with today. So I want to isolate this and then take the square root on both sides. Okay, so first I'll divide by 3,000 on both sides. And I'll have then 1 plus r squared equals 432 over 300. I can at least cancel out the zeros. Square root property then says 1 plus r equals plus or minus square root of 432 over 300. I'm going to leave it like that. Okay. And then just sort of figure out my answer. So it would be r equals 1, negative 1 rather, so I have to subtract 1 from both sides. Negative 1 plus or minus square root of 432 over 300, and now put those into my calculator, sort of figure out what's the right answer, and it turns out to be this part, the 1 plus square root 432 over 300. And the approximation I'm getting is 0.2. Okay. So our rate is 20%. If you convert this over to a percent, by moving the decimal place 2 places, you would get 20% as your rate. And the next thing I want to look at is the Pythagorean Theorem. And the Pythagorean Theorem says if you have a right triangle, okay, so here's my right triangle, if you square the legs and then add them together, that will equal the square of the hypotenuse. Okay? So this is a leg, that's the hypotenuse here. The hypotenuse is the longest side of the triangle. Okay? So our formula is a squared plus b squared equals c squared. Okay, so let's look at an example of that. 115, it's an application. There's a ladder, I guess, of some sort, which is, I think, 30 feet long, leaning against a building. And the base of the ladder is 10 feet away from the building. And then they want to know what is this height right here? Okay, so what is this height on the side of the building? So you can use Pythagorean theorem to figure this out. This right here is a right angle. The right angle is 90 degrees perpendicular. Okay. So I'll just take my values, x squared, the leg squared plus the other leg squared is equal to 330 squared, and then solve for x. So x squared equals 30 squared, which is, I think, 900, minus 10 squared, which is 100. Square root property, x is plus or minus square root of 800. Of course, we don't want the minus version, right? So we don't care about that because we're talking about actual distances on a triangle. So that's approximately then 28.28, and the units are feet. So the ladder, or this distance on the side of the house, is a little less than the ladder distance. Okay, so what do I care? The Pythagorean theorem leads into the distance formula. Okay, so the distance between 2 points in a plane, you can figure out using the Pythagorean theorem. You can figure a formula for it. Okay, so section 4, distance formula. So here's our xy plane, and we want to know the distance from this point to maybe this point over here. So how do I figure that out? Well, you can draw a triangle. This point should be maybe over here a little bit. The distance you're interested in is this distance, which is basically the hypotenuse of this right triangle. Okay. You can figure out this distance here, the distance of this leg, just by subtracting this x2 minus x1. Okay. In order to keep it as a distance, in case somebody is trying to trick you and put x1 on the other side, we're going to think of it as an absolute value. So you'll take x2 minus x1 and take its absolute value. And that'll give you the distance of this leg. No matter whether you put x1 over here and x2 over here, or x1 over here and x2 over here. It's like 5 minus 3. The distance between those 2 points is 2. 3 minus 5, the distance between those 2 points would seem to be negative 2, but then if you took an absolute value, it would be back to 2. Right? So that's what we're after with the absolute values. And then the distance from here to here is just the difference of these y values. And again, we think it in terms of an absolute value of that difference. And then the thing that we're interested in is this d distance from here to here. So from Pythagorean Theorem, all we have to do is take this squared plus this squared, and that'll equal this squared, and then we can solve for d. So what did I say? D squared is equal to this guy squared. And if you square something, it'll automatically be positive. So we don't need the absolute values. And then plus the other leg squared. Okay. And then to get our answer for the distance, we take the square root of both sides. And we don't care about the plus or minus because we're actually looking for a positive value here. And there is our distance formula. Okay, so if you have that formula, you should be able to construct the distance between any 2 points in the plane without graphing them. So 73, we have 3.5, comma 8.2, and then negative 0.5, comma 6.2. And we want to know the distance between these points. So I'll just say this is my x2 minus x1, negative 0.5 minus 3.5 squared, plus y2 minus y1. And it kind of has that slopey feel when you build it, ain't it? It's kind of like the pieces of slope, and you're putting them into the distance formula. And that's kind of an important observation later on in life. In the life of a math person. Anyway, 6.2 minus 8.2, and we go and square it. Okay. And that'll be, believe it or not, 16 plus 4 when all is said and done. And then, of course, that's square root 20, and then we can march out the perfect squares. So that would be 2 root 5. Okay. And humanoid terms, I guess I don't have an approximation, so we'll just leave it at 2 root 5. Okay. Okay. The midpoint formula then, the last thing we want to look at is just going to be it's more about averages of the x value and the y value. I'm not going to go through the theory like I did before. To get the midpoint between 2 points in the plane, what you do is just average the x coordinates. So you take x1 plus x2 and divide by the number. There's 2 of them, so divide by 2. And then do the same thing with your y coordinates. You just add the y coordinates and divide by 2. And that turns out to work. Okay? So 87 has a bunch of fractions in it. Let's take a look. Negative 7 halves, comma, I have no idea what I wrote, 3 halves. And then negative 5 halves, comma, negative 11 halves. Okay. So you take the x coordinates, negative 7 halves, and then plus negative 5 halves, and that's all over 2, comma, 3 halves plus negative 11 halves, all over 2. Negative 7 halves plus negative 5 halves is negative 12 halves, which is negative 6 over 2. 3 halves minus 11 halves is negative 8 halves, which is negative 4 over 2. And then, of course, that's just negative 3, negative 2. Okay, that's it. See you next time. Bye.